Welcome to Study Loop.
19.33. So we have this kind of wacky looking circuit drawn here, and I've gone ahead and labeled the currents through the various branches of this circuit. And first we want to find the total current going through the battery. Then we want to find the equivalent resistance of all this using that current. So we start writing down Kirchhoff's rules. So we have a current I entering this junction, and I1 and I2 leaving it. I2 gets split up into I3 and I4. And then I1 and I4 combine back to be I5. So this is all of that we need. Now we can use the loop rule. So starting with this loop around these resistors, we have 0 equals negative I2R minus I4R plus I1R going through the loop here to here, and then here, and then all around again. We get 0 equals negative I2R minus I3R plus the EMF of the battery. So we're going all the way around there. And then going through this loop, we get a negative I3R plus I5R plus I4R is equal to 0. So now we have 6 currents we don't know and 6 equations. And so what you can do is go ahead and solve these by substitution. You eliminate I5 and then I2, and then you can get rid of 4, etc. And we don't need to go through all that right here because it's sort of a simple matter of, you've done this before. So what we end up with when we do this is we find that the total current is equal to the EMF of the battery divided by the resistance of one of the resistors. And from this, more or less immediately, we see that the equivalent resistance here is the resistance of one of the resistors. Even though this is, some goofy, complicated arrangement, it's been sort of contrived so that the total resistance here is R. And if we want to be especially picky about it, we can just write this out. The equivalent resistance is equal to the EMF divided by the total current. The total current is E over R. And so we're just left with R as the equivalent resistance.